Welcome to the next learn. We're looking at the use of scientific notation. So, when using very large or very small quantities, it is important to choose the appropriate size of measurement. So, for example, is it more appropriate to represent the distance from California to New York as 2,441 miles as opposed to 1.55 times 10 to the power of 8 inches? Oh my goodness. 8? 10 to the power of 8. Look at this. 10 to the power of 8. That tells me I have 8 zeros. So 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, comma, 1, 2, 3. 3, comma. So that is almost 100 million inches. That's crazy. We normally talk about it in miles. So now, circle the units that are more appropriate for measuring the following. So the time it takes to travel from Florida to Michigan. Usually, when we're talking about traveling from state to state, we talk about hours. So hopefully, you circled hours. So now, try the next one, the thickness of a penny. What would make sense? The thickness of a penny. Hopefully you said millimeters because meters, that's 3 feet. Would it make sense to talk about the thickness of a penny in 3 feet? No, but millimeters are a lot smaller. All right, the length of a football field. Do we want to talk about it in miles, in feet? How would we want to talk about it? Definitely yards. We talk about it in yards. Definitely inches are way too small. And then the weight of a paperclip. The weight of a paperclip. Ounces. Definitely ounces. Pounds are usually for larger things. Think about babies. We talk about babies in ounces, not really pounds. We do include ounces with our pounds. All right, you can estimate very large or very small numbers by expressing them in the form of single-digit times as integer power of 10. So let's talk about what that means. So single-digit times. They're just saying that you should have your factor, while it's going to be between 1 and 10, we're going to use estimations. Estimate using whole numbers. It's just the idea of using whole numbers. That's it. Whole numbers. All right. So integer power of 10, estimate using very large or very small numbers makes them easier to work with. Complete the examples to estimate the numbers. So the population of the United States in recent years was 324,430,860. So notice how there's this symbol right here. So this symbol means approximately. Approximately. So that's what this symbol means. It's not Aquarius, it's not a sign like that. It just means approximately. So that means we can take this big number and make it look a little bit prettier by putting a bunch of zeros past it. And notice how the second number was a 2 after the 3, so that's why we could round down. If we had a bigger number like 36 or 360 million, I would probably estimate that to be closer to 4 million or 400 million. Okay, so it's that idea that we're still using the numbers after it to see if we should go up or down. So next we should get 3 times 10 to the power of 8, because look, we have 1, 2, 3, 4, 5, 6, 7, 8. We moved it 8 place values. So when we're talking about the diameter of an animal cell that was measured at this number of centimeters, we're going to approximate by just eliminating those last 2 numbers and doing 0.0006. So we get 6 times 10 to the negative 4. So notice how our factors are now whole numbers. If we didn't have whole numbers, I would actually have 6.35 times 10 to the power of negative 4. But we're doing estimates. All right, example, choose units of appropriate size. If you could walk at a rate of 2 meters per second, it would take you 1.92 times 10 to the power of 8 seconds to walk to the moon. Is it more appropriate to report this time as seconds or in years? Explain your reasoning. Seconds. Do we want to think about seconds going to the moon? Or would it make more sense for us to think about it in years? So representing the time in seconds gives a large number. So the 1.92 times 10 to the power of 8 seconds, or 192 million seconds. It would be more meaningful to represent the time as 6.09 years. So choosing the larger unit of measurement is more appropriate for this situation. So the measure of 6.09 years is more appropriate. So go ahead and read the check. A plant cell has a diameter of 1.3 times 10 to the power of negative 8 kilometers. Is it more appropriate to report the diameter of a plant cell as 1.3 times 10 to the negative 8 kilometer, or 1.3 times 10 to the negative 2 millimeter? So we're talking about a plant cell, and then they talk about kilometers or millimeters. Which one's smaller? Our millimeters are smaller. All right, next example, we're going to estimate with scientific notation. The population of Missouri is 6,063,589 people. Write an estimate. So when we write an estimate, that just means I'm just going to say 6 million people. And so now in scientific notation, I have a 6, and then I move 1, 2, 3, 4, 5, 6, 10 to the power of positive 6, because my number was big. So let's check it. Yep, we got it. All right, your turn to try. Now that you've tried it, let's check. The distance from Earth to the moon is this many miles. Write an estimation. So I'm going to estimate 200,000 in scientific notation. So that's going to be 2 times 10 to the power of 1, 2, 3, 4, 5 times 10 to the power of 5. Let's check our answer. And that's what we get.